Welcome to Math 8 Review, Unit 1A, Lesson 4, Combining Like Terms. The important thing in this lesson, after this lesson, you will be able to identify and combine like terms in an expression and put it in simplest form. We're also going to look at some equations where we'll need like terms. So let's first define like terms. In an algebraic expression, like terms are terms that have the same variables raised to the same exponents. Constant terms are also like terms. That word constant means they stay the same. So think of things that are constant in your life. They're always the same. So a constant would be something that does not have a variable. So first, we're going to write the expression as a sum of its terms. So we've started with these like term expressions. So it says like terms are terms that have the same variables raised to the same exponents. So this is 12g, which is really like 12g to the 1 and 9g to the 1. I think about this as 12 cookies and 9 cookies, or 12 cupcakes and 9 cupcakes. I just add the coefficients, that's the number in front of the variable. 12 plus 9 would give me 21, and the g comes with us. This one, 11x plus 9 minus 7. Well, there are no other terms that have an x, so the 11x stays, and my 9 and 7 get combined. 9 minus 7 gives me 2, so 11x plus 2. My third one, I do have some like terms here. I like to circle my like terms, so 8 and 6.2, I like to keep the sign in front. So 8 plus 6.2 is 14.2, and I'll switch and say, okay, plus 4a minus 9a, imagine we've already reviewed integers, positive 4, negative 9, subtract them in your head, so 9 minus 4, and keep the sign of the bigger number. So you're going to say that's going to be minus 5, and the a comes along. Now we're going to learn something called standard form, and that means the variables always come first. You may know that already. So I'll rewrite this as negative 5a plus 14.2. Our next examples have some fractions. So this is 2/5 y, and this is negative 9/10 y. So yay, we get to get a common denominator. So you can probably see that if I multiply both of these by 2, I can change this to tenths, which is going to be nice. So I'll have 4/10 y. I can now combine these guys because I know minus 4 and a positive 7, they're different signs, so I subtract them. So 7 minus 4 gives me 3. Keep the sign of the larger number. And I'll just rewrite this as is. So 4/10 y minus 9/10 y. So you have to think to yourself, okay, so 9/10 minus 4/10. Remember, when we add and subtract fractions, we subtract on the top or add on the top. 9 minus 4 gives us 5. Keep the denominator 5/10. And which one's bigger, the 9/10 or the 4/10? So imagine, you think there's more slices there. If you are looking at the 9/10, you keep the sign of the bigger number, which is negative. Negative 5/10 can reduce to negative 1/2. So this can really be written as negative 1/2 y plus 3. There's our final answer. And our last problem has more fractions. And here I see that I've got a negative 2/3 c and a negative, the only other c is a positive 14c. So this one's kind of nice because you can think to yourself, well, they're different signs. So because they're different signs, I subtract. So think 14 minus 2/3. Well, there's 3/3 in a whole, so really I'm not down to 13 yet. I'm down to 12 yet. I'm just down to 13 1/3, right? So I'm just taking away 2/3. So I would say 13 1/3 c. And now negative 9/5 and positive 3/10. So again, that same concept, multiply everybody by 2. So I end up with negative 18/10 plus 3/10. Signs are different, so I'm going to subtract. So 18 minus 3 gives me negative 15. keep the sign of the larger one, over 10, reduce it, you end up with -3/2, which we know is really -1 1/2. So this would be -1 1/2. All right, let's look at the next page. So here we are trying to solve an equation. Variables are on both sides, and these are involving our like terms, and you'll see why. So I'm going to go straight down to this problem where we say, okay, we'll put our line down the middle, and we need to get our variables on one side. So I think you'll agree with me that it would be very quick to move my 2x's to the other side. And when I do that, I end up with a -3x minus 2x would be -5x equals 20. Here we have a one-step equation. We divide both sides by -5. This cancels out and you're left with x equals -4. Your laws of exponents again, positive divided by a negative gives you a negative. This one has some decimals. Again, I like to put a line down the middle just to start. I see y's on one side and y's on the other side. My job is to get them on one side, so -2.5y. We are far along in our math now that we could do a double up on steps. I want to get my variables on one side and I want to get my numbers on the other side. So if I added 1 to both sides, which I'll show in red, I could do this all in one step. So these will cancel out. 6 plus 1 gives you 7. 4.5 minus 2.5. 0.5 goes to 0. 4 minus 2 gives you 2. Y. So now you need to divide both sides by 2 to clear and get your variable alone. And you'll end up with 7 divided by 2 is 3.5, or 3.5 gives you y. And our last examples involve a distributive property. So these are fun. You get to use that distributive property and say 6 times 4 gives you 24. 6 times -z. This is the same thing as a 1, which we often put in as a placeholder. So I'm going to say -1 times 6. Well, that's like -6z equals 2z. And now you're back to the problems like the prior page. So you could put your line down the middle, add 6z to both sides, and you'll have 24 equals 8z. And you can now divide both sides by 8 and have 3 equals z. Our last problem has decimals and a double distributive. So 5 times w is 5w. 5 times -2 minus 10 or plus a -10 equals -2 times 1.5. It's going to stay negative because 1 is negative. 2 times 1.5 is 3, so -3w minus 10. -2 times 5 is 10. Put your line down the middle if you like. You can add 3w to both sides. And I'm going to do this in one step. I'll add 10 to both sides. This is going to be interesting because look what's going to happen. So you've got 5w plus 3w gives you 8w. This cancels out. This cancels out. -10 plus 10 gives you 0. So you have 8w equals 0. Finish it off. Divide both sides by 8. And you have w equals 0 divided by anything is 0. If that 0 were on the bottom, it would be undefined, but it's on the top. All right, that sums up combining like terms. Thanks for watching.